All right, so we did Rolle's theorem yesterday, right? So if you're continuous and differentiable, your endpoints are the same, you have a horizontal tangent somewhere. Now this is also a pretty big theorem as well, the mean value theorem. So again, you need to be continuous on your closed interval, differentiable on your open interval. So what this says is that you have a value of your derivative that's going to equal the average rate of change. Okay, so this is all right, so you can think of it as like the calculus way of coming up with slope is equal to more of the algebra 1 way of figuring out slope. So you're figuring out the slope between the two endpoints, and then somewhere your instantaneous rate is equal to that. All right. So if you look at a couple of these graphs, right, we have a line connecting our two endpoints. Right. So what the mean value theorem says is there's got to be at least one point where you have a tangent line that's parallel to that secant line. Right. So the slope here of your secant line is the same slope of your tangent line. Right. So what we're going to be asked to do most of the time is trying to figure out where exactly does that happen. Right. So we're going to need to figure out what that particular x value is. All right, so if you look at the second one, that has a couple. It can happen more than one place, right? This is happening now in two places where your slope, right, your derivative is equal to, if you were to connect a line from your two endpoints. All right. So slopes of your tangent lines, slope of your secant lines on the interval are going to be the same. Instantaneous rate and the average rate are the same. Okay, so determine if the MVT applies to x cubed minus x from 0 to 2. If so, find the values guaranteed by the theorem. Okay, so is it continuous? Yes, it is. And what about differentiable? That's a polynomial, right? So that means I can find its derivative really anywhere. Okay. So both of those check out, which is good. So that means that the MVT will apply. All right. So again, we want to see where does the derivative of this equation, where is it going to equal if I were to figure out the slope between these two endpoints here for that equation. All right, so how you want to set this up is you want to take the derivative and you're going to equal it to the average rate of change. Right, so this is the endpoint minus the first endpoint over 2 minus 0. Right, so this is more of the, the algebra 1 way of figuring out slope. So the change in your y over the change in your x, somewhere the derivative is going to equal that number. Well, we're going to be working on like both sides, right? So we know f prime of x is what? All right, so now we're trying to see where does 3x squared minus 1, the average rate, equal the average rate of change. So f of 2, yep. So if I plug in 2, right, I get 8 minus 2, which is 6, minus 0. F of 0 is 0, over 2 minus 0, which is 2. So we're trying to see where exactly does 3x squared minus 1 equal 3. 3, right? Yeah, 3. Now your goal here is to just figure out what values of x make that happen, right? So you have if I was to connect the two endpoints for this equation, the slope of that line would be 3. So we're trying to see where else do I have a tangent line of 3. So I'm going to add the 1. Divide by 3. So then x is going to be plus or minus 2 over radical 3, which is plus or minus 2 radical 3 over 3. Okay, now, which one can I get rid of? 1. Right, good. So your only answer would be x equals 2 radical 3 over 3. Yes. Well, like say this is a multiple choice question and you got it down to like here, and that was one of the answers, like you wouldn't have to do that. So you don't always have to simplify your, because we're only looking at it from 0 to 2. That's the interval that they give us. So anything outside of that, we're not really that interested in. Yes? Right, yeah, the slope of your tangent line at this point is going to be the same thing if you were to connect a point from x equals 0 to x equals 2. So right, so we have from 0 to 2, right? We figured out that at x equals 0, it's 0. At x equals 2, it's 6, right? So if you were to draw yourself a secant line going from those 2 points, right, we have a slope of 3. So right here at like, I'm guessing, x equals 2 radical 3 over 3, we figured out that the tangent line at that point is the same slope. Right? The orange line would be your secant line, and then the green line would be your tangent. Right? So this is what we got from figuring out like the derivative. Right? So your derivative is equal to somewhere equal to the same slope of that orange line. Well, it's an x cubed, so it's going to have that bend. That's orange. I mean, I know that. This is yellow. That's yellow. Like this is like you're dehydrated. This is like you probably should seek hospital attention. said this is you're probably really dehydrated. This is you probably should go to the hospital because your kidneys are failing. Like. Really? You need to drink more water. All right, number 3. Determine all the numbers that satisfy the conclusion of the mean value theorem for the function x cubed plus 2x squared minus x from -1 to 2. Yes. All right, so again, this is a polynomial, so it's continuous and differentiable, so this theorem is going to work out for us. So I have f prime of x, average rate of change. What is that? That's 2 minus -1. So my derivative, 3x squared plus 4x minus 1. All right, what would f of 2 be? All right, -1 would be -1 plus 2 is 1 plus 1 is 2 over 3. All right, 14 minus 2 is 12. 12 over 3 is 4. Okay, so that's the problem that we need to solve. So if I have 3x squared plus 4x, if I move the 4 over, right, that gives me -5. Right, so this is what I'm going to put into my calculator. That's going to go into y1, and that's going to go into y2. And we only want to look at it from -1 to +2. So again, we're going to try and figure out the intersections. Yeah, but make sure you change your window around. Zero. All right, so our interval we're looking at is just from -1 to 2, right? And we're trying to see where does that equation equal 0. So I don't really need to be that far out. So I can look at maybe like -2 to +2. So that's going to show me a lot easier. y1 would be your derivative. 0. Because we're trying to see where this is, the blue line would be your derivative. So we're trying to see where does the derivative equal 0. So second trace, number 5. Zero. All right, and we want to make sure that this is close to where they intersect each other, and then hit enter 3 times. And second trace, number 5. All right, so it looks like at x equals 0.786, that's our answer. Okay, so what I want you to start getting in the habit of doing is, writing down that answer, and then most likely we're going to have to use it again. So I want you to start getting the habit of storing it into your calculator. Okay? So, we just figured out that our solution was this, right? So you're going to go to your home screen, and you're going to hit X, and then hit Enter, right? That's the number that we just found, right? So we're going to store that as capital A. So you're going to hit this button down here, STO, store, green button, math button for letter A, and then hit Enter. Alright, so again, you're going to hit the variable button, which is right here, and hit Enter, right? That's the answer that we just found. Then you're going to hit store button, STO, which is right above the on button, green button, and then the math button, which gives you the capital letter A, and then hit Enter. Alpha. That was from an old problem. So, right. So how you would write it on your paper now, right? We figured out that X is equal to 0.786, right? Call that letter A, right? So then, if you are, this was a free response question, you know, your reader now knows that you are going to label this as letter A. Yes. Sometimes you have more than one answer. Like you might have, we only had one answer for this one, but you know, sometimes you might have 2 or 3 answers there. So you would, you know, do the process again, right? You go to your home screen, hit X for your second answer, and then store it as B now. And then do the same thing again, store it as C. Yeah, right.